Okay, so we're looking at question 10 on the mixed exercise, S1, probability. Now the first part, both retired, I've got a Venn diagram up here, and for both to be retired is the intersection, very straightforward. Good, so for them to be both retired, we simply multiply the probability because we want both the husband and the wife. That's just 0.8 times 0.4. Now for part B, very straightforward, only one retired, so it's either the husband only or the wife only, but not both. So again, if you look at the Venn diagram, very straightforward, it's 0.38 plus 0.08. Now for part C, again, it's very straightforward. Neither is simply 0.22 from our Venn diagram and the information given in the question. If we look at the tree diagram for the last part, it will help us understand it. We don't actually have to draw out the tree diagram, but it will help us understand it for future questions of this type. So just take a few seconds to have a look at the tree diagram. So we look at the first couple, then we only want, if it's only the wife, does that make sense to you? Followed by what? How can we satisfy that condition? Find the probability that only one of the two husbands and only one of the two wives. Okay, so let's look at this tree diagram and see if we can see how to satisfy the condition they are asking in the question. In order that only one of the two husbands and only one of the two wives is retired, we can say that if the first couple are both retired, then neither of the second couple could be retired. And in that case, we have one husband and one wife of the two couples that are retired. Okay, so that satisfies the condition. The other way to satisfy the condition is that if neither of the first couple are retired, then it is necessary that both of the second couple, both husband and wife, are retired. If only one wife in the first couple is retired, then in order to satisfy the condition, we need one husband only the husband, rather, of the second couple to be retired. We can't have them both, and we can't only have the wife, because that means it's two wives, and the question wants only one of the two wives and only one of the two husbands. So that satisfies the condition. And again, the last one, if only the husband is retired from the first couple, then in order to satisfy the condition, we want only the wife. Okay? So it's only husband and only wife, we multiply. So then finally we add all the probabilities. But you can see that the first two are exactly the same. Both retired followed by neither is the same as neither followed by both. And only wife followed by only husband will work out to be the same probability as only husband followed by only wife. Okay, you can see that. And therefore you can see that the working out is simply two lots of this probability plus two lots of this probability. Okay, two lots of both and neither, and two lots of only husband and only wife. So the final answer is the probability is 0.2016.